Hello, everybody.
Good morning. Happy Friday, June 5th. We are near the end, and this is a fun last section. We are going to learn circumference and perimeter of irregular shapes.
Miss Murphy, you actually happened to cut out briefly, so I'm just going to read that one more time. So our goal today is that we can determine the circumference and perimeter of irregular shapes. Great.
So if we just take a minute, Mrs. Talhami, I just want to look at two important words in there. I see the word irregular. When something is irregular, it means that we don't have, well, it's the opposite of being regular. Remember, a regular polygon has all equal sides. So an irregular polygon or an irregular shape does not have equal length sides. Something else I want to point out in that word perimeter, I like to look at the three letters in the middle. They spell rim. Perimeter, all around the rim. We'll write a definition for that after. Okay.
Okay, so when we look at that first word, circumference, actually, I'm just going to scroll up real quick to the reference table and have you guys see this is the two-dimensional formulas they give us. So we're not doing area right now, that'll be next time, but you could see right here, they actually give us the circumference of a circle. They give us two different formulas that we could use. So I'm going to write them down here in this formula. So you have to excuse the scrolling. I just needed to go back there. So circumference is equal to pi times diameter, or circumference is equal to 2 pi r. I usually just like to stick to one of them. This is my preference, but really it's up to you, especially because it's given to you on the reference sheet. You could choose whichever one you would like to use. So the circumference.
Talhami, when you were going to school, Mrs. Talhami, did you learn cherry pie delicious?
That's what I learned, and that's why I remember it that way.
Yes, me too.
So the circumference of a circle is actually this outside piece right here. That is the circumference of the circle. The measure of the outside of a circle.
Do you realize that that word circumference starts with almost every letter of circle?
That is so cool.
So that's how you can remember that circumference also goes with just a circle, C-I-R-C. Like we would never say circumference of a square, right, Mrs. Talhami?
No, we would never.
It only goes for a circle.
And then Ms. Murphy, before we're saying perimeter. So perimeter is the measure of the outside. So the rim is the way you remember it.
And when she says measure of the outside, we're going to add all the sides,
So
all the length of the sides.
Exactly. You add oops. Some of you remember it as
just put a little N in there.
Oh,
length.
That's why. My bad. I think sometimes my brain works so fast.
Yes, it does. You are a fast thinker and writer. There we go.
And some of you even probably remember it as sum, SOS, sum of sides. That's another saying. So I'm just putting that in there. Whatever helps you remember. Cool. So let's do a couple examples here. Starting with this first example. If I want to find the perimeter, maybe it helps if I just highlight it first. So I know, oops, that's a little too thick. So I know what sides I'm going to try and include here. So that's the rim or the outside. So really, what do you notice there that's extra they gave us we're not going to use?
Well, I see that 10 is on the inside, and that's not part of the rim. So that's just extra information we don't need for this problem.
Exactly. So really, we have ourselves here a parallelogram. So what do we know about a parallelogram to help us find the remaining sides here?
Just like a rectangle, opposite sides are the same. They're equal.
So if the left is 12.2, then the right is 12.2. And if the bottom is 30, then that means the top is 30. So my perimeter, which is with a P, equals 12.2 plus 30 plus 12.2 plus 30.
We add that all up, we get 84.4.
So my perimeter here is 84.4 meters. Because all we did here is we added up the sides. It's a length. Let's look here. It looks like this got cut off, by the way. This should have said millimeters. So let's talk about the outsides. So here we go again. It looks like they gave us some extra information we did not need.
I think we can cross off that altitude of 37 and just add up 41 plus 63 plus 43 plus 47 is 194 millimeters.
And then one
Notice
last.
that the units are staying the same. It's not millimeters square. It's just millimeters. We're counting how many in total.
Now this shape, oops. I'm seeing if I can make a perfect circle. It's close enough.
That's a beautiful circle.
So this is what we're trying to find. Now, specifically here, I can't just add up the sides. It's what shape here? We have a circle. So if I'm doing the circle, I'm going to use circumference. And circumference is
cherry pie delicious.
Good. And if you notice, they gave us the full length here. If you remember from our circle unit, this is called the diameter. Since it goes all the way across and passing through the middle. So circumference equals pi times 42. Now, the problem did not ask us to round, so we're going to just leave it as 42 pi meters. So that is our answer. If they asked us to round it, we could do 42 times pi in the calculator, and we could say this is approximately 131.9 meters, if they asked us to round to the nearest tenth. So really, that's how you find circumference and perimeter. It's all about the outsides. So here we have a couple practice problems. Actually, we have a good handful. I want you to notice some shapes are easy. Other shapes are a little bit more challenging. So make sure you pay attention, because for some shapes, there might be some missing sides that you need to find. So really make sure you're paying attention to the perimeter or the outside. Okay, so some are a little bit more challenging. If you want to pause here and come back to check your answers, please do so.
Yeah, what do you think about number, let me see, what is that, 2? What is that, 7?
Sure.
Is it 5? Do you think 5 is?
Let's do number 7. That's a great idea, Miss Murphy. So if we take a look at number 7, we're just going to do a few more with you, I guess, before you try them on your own. So what's the first thing you'd probably pay attention to here, Miss Murphy?
Well, I'm noticing that we have 1, 2, 3, 4, 5, 6 sides that are not labeled. And the first side that seems to be the easiest to label to me is across from the 6 centimeters. That also would be 6 centimeters. That seems pretty obvious. What I'm wondering about is, can we fill in the top part of this capital T?
I think we can. I think what we also should notice here is we have these hash marks. So if we have these hash marks, that means all of these segments are congruent. So if this down here is marked as 2 centimeters, that means this is 2 centimeters, and this is 2 centimeters, and this is 2 centimeters, and that's 2 centimeters. Which should,
then we're almost there.
yep, which should be enough of information, because if I put myself, I'm going to put a dotted line here because it's not part of the perimeter. I know that this length has to be 2. So what's this whole length here?
2 plus 2 plus 2 is 6.
So that means,
and that seems to be exactly the same length as the very top.
which is also 6. So notice how this is not really drawn to scale. It's not drawn to scale because this is 6 and this is 6, even though they don't look the same length. So don't go by what you think it is. Go by what you mathematically can calculate it is. So I have 2 plus 6 plus 2 plus 2 plus 2 plus 6 plus 6 plus 2. So make sure only add up the outsides. Do not add this extra piece in the middle.
Okay, so I'm just going to count how many 2's there are. There's 1, 2, 3, 4, 5 2's. So 5 times 2 is 10. And 3 6's are 18. So 10 and 18 is 28.
Very good.
No calculator needed.
So there's one example. An irregular shape. Let's look at number 9. Here's another example you should be able to do now on your own just based on what we just did.
Yes. Yes. Now that we really remember what those hash marks are again.
So that means every one
So
of
we
these
can come
hash
back to
marks
that one.
So every one of these hash marks is a 3.
I'm going to count up how many 3's we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 10 3's, which is 30. And then we have another 10 on the left. So 30 plus 10 is 40 plus 10 is 50 centimeters. There we go.
All right.
That's not so bad, Mrs. Talhami.
It's not too bad. Let's do a couple more examples. I think we should do 15.
The reason being is that 15 has 2 semicircles at either end. And we also have straight lines. So we're actually combining circumference and perimeter in the same problem, aren't we?
Yep. And if this piece is 30, and it's part of a rectangle here, that means this piece must be 30. Now here,
right.
this piece right here is half of a circle. So it's half of pi times diameter. Now, do we know the diameter if this was a full circle?
Yes, we do.
What does it say the diameter is?
The diameter is 10.
So
goes all the way across.
Half of 10 pi is how much?
5 pi.
So we have 5 pi. So 5 pi on this side. And we have 5 pi then on this side, because if this is 10, then that means that is 10. So it works out. So really, our perimeter here is 30 plus 30 plus 5 pi plus 5 pi. So it's 60 plus 10 pi. I cannot combine something that has pi with something that does not have pi. So if I want an exact answer, that would be my exact answer. If I want it rounded to the nearest, tenth, let's say, I would do 10 times pi, and then I would add to it the 60, which is about 91.4 centimeters. So that's kind of how you complete these problems. You really have to highlight for yourself what parts we are adding up. Should we do one more?
Okay, so we can probably, do we have one more to cover?
We could do one more, unless you want to give them the rest a try.
Mm-hmm.
What do you think, Ms.
Let's look over at, we don't have to do it together right now, but we can start them off with 17. I see a rectangle and a right triangle.
Oh.
You remember how to find the hypotenuse of a right triangle. So you can actually think of those as two different shapes for right now.
So notice how I label everything I know, even though I highlighted the perimeter. Now, Ms. Murphy said let's focus in here, in this shape, to get ourselves this remaining piece. We could use leg squared plus leg squared equals hypotenuse squared. So my two legs are 6.9 and 5.
Okay, 6.9 squared is 47.61. Plus, oh, you did it all together, plus 25.
Mm-hmm.
Yep, 72.61. Square root key looks like a check. It takes away that 2. Square root of 72.61 is approximately 8.52. We'll write it all out, I guess, to find that missing side.
So that's what this represents.
52,115,0157.
So my final perimeter, if I add those up, 8.52,115,0157 plus the 4.1 plus the 5 plus the 4.1 plus the 6.9 gives me
28.2,115,016. Or 016, I should say.
So really it's about 28.6
centimeters.
And I know it didn't ask us to round, but since for this one we had no choice but to round, that is our answer. So, do you think they can handle
As
some
long
of the
as we
rest?
understand the process and the formulas. I do. I have full confidence in them.
It starts off a little easier, gets a tiny bit more challenging, and then really tests their ability down here. So, just so you know, give it a shot, pause the video, and come back whenever you're ready. Okay, so hopefully you completed the practice problems. The first 6 are pretty straightforward. You have the answers there. Ms. Murphy and I decided to keep it as exact answers. So it's really important for you to really recognize every part of the picture. Something Ms. Murphy and I brought up at number 8, really important for you to see. Some of you might recognize this is half a circle, so you did half of pi times diameter, and you got 5 pi. But if I were to truly, if this was the shape of a track that I had to run around, I would have to walk the curve and the straight. So you have to remember, if I'm doing the full perimeter, I have to add 10 more centimeters to get the full perimeter. So that's why I highlighted. Anything that's highlighted needs to be added to the perimeter. Here we have our isosceles triangle. In number 11, some of you are able to recognize that that's 3/4, like almost like 3/4 of a pizza. But if you don't recognize that, what you do see is they took away 90 degrees. So 360 minus the 90 is 270. So that means this remaining piece is 270. 270 out of 360 is the same thing as 3/4. Your calculator can reduce that for you. So 3/4 of pi times diameter, which the diameter here would be 4. That would be 3 pi. Plus, don't forget, when I finish the 3/4 of the circle, I have to walk this straight, which is 2, and this straight, which is another 2. So that's adding 4 more. Then looking at number 12, we had a missing side, but we had a right triangle. But we had 2 of the 3 sides, so we easily used the Pythagorean theorem. We got the third side was 12, and then we were easily able to find the perimeter.
That's one of those nice Pythagorean triples, 5, 12, 13.
Absolutely. Here's another one that talks about a piece of a circle. Now you could have done, hey, I have 90 out of the 360, and that would have reduced to 1/4, or some of you can recognize this is a quarter of a circle. So if the quarter of the circle plus the 2 straights.
4 and 4 is 8.
Then for number 14, it was pretty straightforward. 15 we did together. Looking at number 16, you really have to look deep into this one, because these straight lines add up to 68. But now I have a small curve here and a large curve here. So with the small curve, if I were to complete this circle, well, that was a bad completion, but you guys kind of probably get my idea. I would have that the diameter is 4, so I have half of a 4 pi circle. Then if I did it to this larger circle, what you would see, the whole diameter here would be 4, 8, 12. So half, this is only half of 12 pi. So that's where we got the 6 pi. 6 pi's and 2 pi's gives me 8 pi's, and these straights give me 68. Then if you look at number 18, because we did 17 together, if you look at number 18, there's 2 possible ways you could have gotten this third side. Some of you could have done Pythagorean theorem and got the square root of 32. Some of you may have noticed that it was a special right triangle, x, x, x rad 2. So this is 4, 4, 4 rad 2. So either one of these answers were acceptable unless we said in simplest radical form or in simplest form, then you would have to give this answer. But luckily for you, if you can get this far, that's wonderful. You would receive almost all the credit. You would only lose 1 point for not being able to reduce. If it's a multiple choice, you could easily pick out which answer matches by doing the math in the calculator. Find out approximately, decimal-wise, how much it is. Then for number 19, you got to cut it into different shapes. So you got half a circle, you got a rectangle here, a rectangle there. For number 20, I didn't recognize that it was another special right triangle. Miss Murphy was thinking that maybe we can use SOHCAHTOA, which we could have, but maybe our answers would not have been exact because it would have given us a decimal here since this is an irrational number. So if I asked you to find an exact answer, you would have to know the special right triangle rule, which we wrote over here. And then one of the most challenging, like I said, these bottom ones were going to be a little bit more challenging. In number 21, originally it's a big right triangle with an altitude drawn to the hypotenuse. That's a Hills or Sass problem. I only knew these pieces down here. So to find the first side, I used Hills. Hypotenuse over leg equals leg over segment. So that's how I found that this leg is 6. Then once I know that this side is 6 and this side is 9 in this big right triangle, we did the Pythagorean theorem to find this third side here, which you could have gotten either the square root of 45 or 3 rad 5. Again, either answer is acceptable unless we said simplest form, then you'd have to have this answer. So that's how you find circumference and perimeter. You really have to break down your shapes. You really have to think back to the rules and properties that we've learned about all these different kinds of shapes.
Wonderful. So we're following up now, 5-question practice. Castle Learning number 20 for June 5th.
And if
Have
you
a wonderful afternoon.
You too. And if you have any questions, make sure you reach out to us, please. Bye.
We're here for you. Bye.